Hello. So for this video, we will be solving the A problem for A part 2 of our mixture application of first order differential equations. Okay, so the problem goes, a 50-gallon tank initially contains 50 gallons of fresh water. At time is equals to 0, a brine solution containing 1 pound of salt per gallon is poured into the tank at the rate of 2 gallons per minute. While the well-stirred mixture leaves the tank at the rate of 2 gallons per minute, or same rate. Okay, so find the amount of salt in the tank after 10 minutes. So the problem goes, we have a tank, okay, with a volume of uh, 50 gallons, okay, and then initially, it is filled with fresh water, okay. Now, a brine solution will be introduced containing 1 pound of salt per gallon. Okay, as the concentration, and then at a rate of 2 gallons per minute. Now, this concentration or this mixture will leave the tank at a rate of 2 gallons per minute. So the question here is, find the amount of salt in the tank after 10 minutes. Okay, right. So as I've suggested in the first video or the part 1 of our mixture problem, we will approach a mixture problem in its differential equation form. So concentration in, let's call that C in. Let's make our equation cleaner, times flow rate in, okay, minus concentration out times flow rate out. Okay. So looking at our given, concentration in is 1 pound per gallon. Okay. Times flow rate in, which is 2 gallons per minute. Okay. Minus, so concentration out is Q over the volume. So in this case, 50 gallons. Okay. Times flow rate out, which is 2 gallons per minute. Okay. So simplifying our working equation, we will have, so gallons will be cancelled. So dq over dt, okay, is equals to 2 or 2 pounds per minute, okay, minus, so 2 over 50 will be q over 25. Okay, so this is now the resulting dE of our mixture problem, which as you can see is not, okay, is not a call this one variable separable problem. This is solvable using variable separable, but I will try to highlight that this is also a, if you arrange this in this order, so plus 1 over 25 q is equals to 2. Now, this is a linear dE or first order linear dE. Okay, so we will try to solve this one using our first order linear dE solution, right? So dq over dt plus 1 over 25q is equals to 2. So step 1 of our linear dE, we will solve for v, which is integral of e raised to p of x dx. In this case, dt, p of t dt. Okay, so e raised to, our p is 1 over 25 dt. So v is e raised to 1 over 25 t. Okay, and then multiply this to our linear DE. So we will have e raised to 1 over 25t. Okay. And then on the left side, we will have v times y, or in this case, e raised to 1 over 25t, sorry, e over 1 over 25t times q is equals to 2 e raised to 1 over 25t. Okay, so we will integrate the right side now. Then this one will be equal to e raised to 1 over 25t q is equals to, okay, so the integral of e raised to 1 over 25t, so 2 over 1 over 25, sorry, e raised to 1 over 25t, okay, plus c, right? Then 2 over 25, simplifying this one, will be equal to 50. So we will have e raised to 1 over 25t cube is equals to 50 e raised to 1 over 25t plus c. Then we can simplify this one by multiplying both sides by e raised to negative 1 over 25t. So q is equals to 50 plus c e raised to negative 1 over 25t, right? Then, as mentioned earlier, so the tank is full of fresh water, okay, at the start. So at time 0, the amount of salt in the tank is also 0, okay? So 0 is equals to 50 plus c e raised to negative 1 over 25 times 0. Okay, so again, this one will be equal to 1. So c1 now is equals to negative 50. Okay. So our working equation will be q is equals to 50 plus 50. Sorry, this is c, that's c1. And this is negative. So 50 minus 50 e raised to negative 1 over 25 t. Okay, so this will be our working equation. And then as for our next question, we are looking for the amount of salt inside the tank, okay, at time is equals to 10 minutes. So plugging this into our equation, so q is equals to 50 minus 50 e raised to negative 125 1 over 25 times 10. Okay, so 50 minus 50 e raised to negative 2 over 5. Now this one will have a units of pounds. Notice that this is the format of our answer, meaning the maximum amount that can be subtracted here is 50. So the amount of salt, the least amount of salt possible is 0. Okay, and also this can be 0 after some time. So the maximum amount of salt into our tank is 50 pounds, or the tank will be full of salt instead. Okay, so that's it for our part 2 or second problem, second example of mixture application of first order tea. Thank you.